Hello, it's me, Mohammad Osman from Mr. Tablet. And today we have our last video on the series of naming organic compounds. And today we are going to see very carefully the naming of organic compounds with polyfunctional group. Now, when an organic compound contains more than one functional group, we call them polyfunctional organic compound. So, for example, this carbon has a OH group, which is hydroxy group or alcoholic group. Also, this carbon contains a C double bonded OH group, which is a carboxylic acid group. Now look, the same carbon contains an alcoholic group as well as a carboxylic acid group. So what is going to be the name of this compound? Well, this remains the question. How do we name them? To name them, we need to follow a priority list. So to name such compounds which contains a polyfunctional group, we need to follow a priority list. Now, what is a priority list? Let's see. Now, this is what a priority list looks like. Carboxylic acid is at top. It has been ranked 1, then followed by sulfonic acid, which has been ranked 2, followed by acid halide, which has been ranked 3, and like that, alkane is at last of the priority list. So from here we have the highest and down we have the least priority group. Now, to understand this better, we can see an example. Now we have our first example over here. If we look at this compound, we have 3 functional groups in total. We have this aldehyde group, which is the CHO group. We have this, you can tell it, carboxyl group or ketone group, whatever you may say. And we have this hydroxyl group or alcohol group. Now look, one single compound has 3 functional groups in total. Now what is going to be the ultimate main compound? Well, to determine that, we need to look at the priority list. Look, aldehyde comes above both ketone and alcohol. Aldehyde will be ranked 1, ketone will be ranked 2, and alcohol will be ranked 3 in case of this compound, for this compound. Alright. So, ultimately this whole compound becomes an aldehyde compound. The class of this whole compound becomes an aldehyde compound. Why? Because aldehyde is at top, is above both ketone and alcohol. At the same time, this OH group becomes a substituent group, and this double bonded O, this ketone group, also becomes a substituent group. So let's name this compound. Remember that CHOC is always numbered 1. This carbon will be numbered 2. This carbon will be numbered 3. This carbon will be numbered 4, and this carbon is going to be numbered 5. So the name of this compound is going to be 4-hydroxy. Look, this hydroxy group is at 4th position. Remember, this hydroxy group, this oxygen group has now become a substituent group. Why? Because CHO, the aldehyde group, is the main group. It determines the total class of this compound. This total compound has become an aldehyde. Why? Because aldehyde is above both ketone and alcohol. So 4-hydroxy, because hydroxy group is at position 4 or is attached to carbon number 4. Then we have 2-oxo, because this oxo group, which is also a substituent group, is connected to carbon number 2, 2-oxo. How many carbons we have in total? 1, 2, 3, 4, 5. 2-oxo pentanal. Why pentanal? As I have stated that this whole compound is an aldehyde because there is presence of CHO, and CHO is above ketone and alcohol. So the name of the compound stands as 4-hydroxy 2-oxopentanal. Alright. So this is our first example. Another question that can come to your mind is, why did I place hydroxy first and oxo second? Well, you see, in alphabetical order, H comes before O. That's why we placed 4-hydroxy first and then 2-oxopentanal. Let's move to our second example. Now in the second example, we also have three. Do we have three functional groups? No, we have two functional groups. We have this aldehyde group, and we have this alkene group. And this is always a substituent group, which is a chloro group. All right. Now, this is a bit different, this example. Previously we considered both this hydroxyl group and this double bonded oxygen as our substituent group. But whenever there is a double bond, we don't consider it as a substituent group. All right. Now let's see which one is ranked higher. Is it CHO? Is it my aldehyde group, or is it my alkene group? Look, definitely aldehyde is ranked way too above than alkene. So this entire class of compound becomes a aldehyde. Now remains this alkene. Now always remember, for alkene, this doesn't become a substituent group, but it adds with the main chain. When I will write the name of this compound, you will understand better. But the main compound has become an aldehyde because CHO is way too above alkene in the priority list. Now let's name this compound actually. The name of this compound becomes, okay, let's rank. Let's number it. So definitely CHO carbon is always numbered as 1, 1, 2, we have 3. This carbon is going to be 4, this carbon is going to be 5, and this carbon is going to be my 6th carbon. All right. Now, this chloro group is placed at 4th carbon, so this is going to be 4 chloro. Then, how many carbon in total? 6 carbon. Hex, 4 N. Look, because this double bond starts at 4th number carbon. Now see what I was saying actually, that this double bond will not be considered as a substituent group. Rather, it's gonna be written in the main chain, like 4 in. We didn't consider this as substituent group, but the main compound, the entire compound is the aldehyde class because CHO is above alkene. Now then, after 4 in Al. Why Al? Because as we said that this entire class of compound is an aldehyde. So let's repeat. 4 chloro. Why C first? Because in alphabetical order C comes first. 4 chloro hex 4 in. Look, we wrote this in with the main chain, while naming. 4 in Al. Why Al at last? Because the entire compound is an aldehyde. 4 chloro hex 4 enal. Alright, so we have our last example for today. If we look at this compound, we have two functional group again. This is an aldehyde group CHO, CHO, aldehyde group. Then we have alcohol group, or you may call it a hydroxyl group. And we have a chloro group, which is definitely going to be a substituent group. Alright. Now let's see the priority list. Look, aldehyde comes above alcohol. Aldehyde is at higher rank. So definitely this entire compound is going to be, the main is going to be an aldehyde. This entire class of the compound has become an aldehyde because why? Because there are two functional groups in this compound. One is aldehyde, another one is alcohol. But aldehyde is at higher rank compared to alcohol, and as a result, this entire compound becomes an aldehyde. Now let's name this compound. Definitely we are gonna name this carbon as 1. Always remember to number CHOC as 1. This carbon is gonna be 2. This carbon is gonna be 3. This carbon is gonna be 4. This carbon is gonna be 5, and this carbon is gonna be 6. Okay. So the chloro group is at 5th position. It's going to be 5CHLO-chloro. Then we have our hydroxyl group. Remember, hydroxyl group has now become a substituent group. The exception was only for alkene. Alkene was written in the main chain as a pair, along with the parent compound's name. All right. So we have 5-chloro. Then we have 3-hydroxy. And this entire compound has 6 carbons, so definitely hex. And what is the main compound? It's aldehyde, so hexanal. And why I wrote C before H? Because alphabetically C comes before H. So that's all about naming polyfunctional organic compounds. I hope you have understood the concept of this whole video series on naming organic compounds. If you have any doubt, any problem, please do write in the comment. I will be glad to answer. Thank you so much, everyone.